All 5 SUVAT equations have 4 variables. We may have u, v, a, and t, s, v, a, and t, s, u, a, and t, or s, u, v, and t, or even s, u, v, and a. We have seen the first equation s equals 0.5t open bracket u plus v close bracket. Here we have a formula that includes the distance, the time, the initial speed, and the final speed. We have also seen another formula, v equals u plus at. Here we have in one equation the initial speed, the final speed, the acceleration, and the time. Imagine that we want an equation that includes all the variables except for v. Well, we can eliminate the v. We can substitute the first equation into the second. So we get s equals 0.5t open bracket u plus open bracket u plus at close bracket close bracket. S equals 0.5t open bracket 2u plus at close bracket. S equals t open bracket u plus 0.5 at close bracket. S equals ut plus 0.5 at squared. We have the third SUVAT formula, S equals ut plus 0.5 at squared. Here we have the distance, the initial speed, the time, and the acceleration all in one formula. Imagine we want to eliminate the t. Well, we can rearrange the first equation to give us t equals open bracket v minus u close bracket divided by a. We substitute that formula into s equals 0.5t open bracket u plus v close bracket. This gives us s equals 0.5 open bracket v minus u close bracket divided by a close bracket times open bracket u plus v close bracket. We multiply both sides of the equation by 2a. This gives us 2as equals v minus u times u plus v. We expand that and we get 2as equals v squared minus u squared. We add u squared to both sides of the formula, which gives us v squared equals u squared plus 2as. We have the fourth SUVAT formula, v squared equals u squared plus 2as. Here we have the initial speed, the final speed, the acceleration, and the distance all in one formula. Imagine that we don't want to have the initial speed in an equation. Well, first we eliminate the u. We get u equals v minus at, and we substitute that into the second equation. We work it out, and it gives us s equals vt minus 0.5 at squared. We have the fifth SUVAT formula, s equals vt minus 0.5 at squared. You may not see this formula as often as the other four, but here you know it exists. Let's take a look at an example. A particle moves at an initial speed of 10 meters per second and comes to rest in 20 seconds. State the distance moved and the acceleration. In these examples, remember that we are taking the acceleration as constant. Also remember that we are working in a Euclidean space. Let's take a look at which of the values we know. We know u equals 10, v equals 0, because it says it comes to rest in 20 seconds, and we know t equals 20. Let's work out the distance first. We could also work out the acceleration first. But in this example, let's find out s. We need a formula that includes s, u, v, and t, and we have it. We substitute the values in. S equals 0.5 times 20 times open bracket 10 plus 0 close bracket. It gives us that the distance equals 100 meters. Then we work out the acceleration. We need a formula that includes A. So we can use any of the 5 SUVAT formulas apart from the one we used before. We can use this nice and simple one. V equals U plus AT. 0 equals 10 plus 20A. 20A equals minus 10. A equals minus 0.5 meters per second squared. Let's take a look at this example. S equals 1, U equals 0, V equals 1. What are the values of A and T? Let's use the equation V squared equals U squared plus 2AS. 1 squared equals 0 squared plus 2 times 1 times A. 1 equals 2A. A equals 0.5 meters per second squared. To work out T, let us use the formula we haven't used. S equals UT plus 0.5 AT squared. 1 equals 0 times T plus 0.5 times 0.5 times T squared. 1 equals 0.25 T squared. T squared equals 4. Now, the T, at least in these equations, can only adopt positive values. T equals 2 seconds. Here we have the 5 SUVAT equations. I recommend you commit these to memory. Let's take a look at some exercises. I recommend you try these at home. Please pause the video now. And here are the answers.